human being, we have understood brain.
I have worked on this brain disorder called ALS, which is amyotrophic lateral sclerosis, and the incidence of that disease is claimed to be 1 in 300 people will be affected. So that's a lot, you know.
Dr. Poulomi Banerjee is a principal investigator at the SCAN Medical Research Trust. An alumna of the University of Edinburgh, she has dedicated her career to researching neurodegenerative conditions like dementia and amyotrophic lateral sclerosis, ALS, a body of work that earned her the prestigious International Brain Research Organization, IBRO Award. Ever wonder why you forget everyday things like your keys or a name? If you want to understand how your brain works and protect your cognitive health, this conversation is a must-watch.
I think hear a lot about is dementia.
Yeah.
It encompasses all these clinical features that you might get sleeplessness, you might get memory dysfunction, you might have a problem in your motor symptoms.
Or can they happen early on?
Early onset Parkinsonism, it's called EOPD, a very commonly used term, wherein the onset, previously, as you said, Parkinson's was like an aging related disorder. So generally we would see people affected in the age of 60s, 70s or something. But now, we don't know why, and this is the biggest question. We see a lot of early onset Parkinson's cases. Parkinson's disease, which is called juvenile Parkinson's disease, the onset is even earlier than 40 years old.
Oh.
So they are called juvenile Parkinson's.
In our genetic history of Parkinson's, is it very likely that in their future generations they might develop?
Am I like 100% sure I will get the disease? The answer to that is no.
Students from college, they all of a sudden enter your lab. What exciting things they can expect?
They will see people are working. It's not the equipment that makes a lab. They will see people probably thinking and asking questions and probably doing some experiments.
Do I need to do a PhD to do a meaningful research?
I don't think so.
Dr. Poulomi, thank you and welcome to this platform. Today I was thinking what to ask you.
Oh, wow.
And while I was looking back to your academic, the path which you have treaded with, and so I thought, why not ask with a simple question?
Fair enough.
Right?
Yeah.
And this question is, how would you like to describe yourself?
If you look into given that you said it's a career path thing, so let me go down my memory lane a bit. It all started, when I moved from Calcutta to Bangalore, and I was very interested in the field of biotechnology that time. There was this big, snaz in that term, biotechnology. So I came to Bangalore and I joined PESET, it's a People's Education Society in Bangalore. So from that time, it was like I was very fascinated with biology, to be honest. But now if I come back, it's like you are saying I'm a neuroscientist and I'm leading a lab here at SCAN. Now, if you ask me back when I was 18, well, I did not wake up one day and think that, oh, I'm going to become a neuroscientist. So it was very organic, it was very, very gradual curiosity that I developed in the area of neuroscience, starting from a very basic question: how does the brain work? So one after the other, opportunities came and I dived into that question: how does the brain work? What makes, the second layer of question was, what makes human brain so special? Yeah. So these are as I said, it's very organic. It was like one opportunity to the other. It was never one fine morning, oh yes, neuroscientist, that's what I'm going to become. I would say that it's a very gradual process. I would hint, the important word here is the process. So I really like that. So yeah. more like a brain function. Then gradually it's like how the cell in the brain, they communicate one another. What makes us think? Why am I so curious? So kind of these questions, it led to this path.
Yeah, that's interesting because in our human body we have different organs and all interesting in their own way.
Yeah.
And brain is one of the most fascinating organs.
Absolutely.
How much do you think we, as a human being, we have understood brain?
I would say we have understood very little. If you think about the diseases that concerns brain in the real world, if you look at dementia, one in I have worked on this brain disorder or a motor neuron disorder called ALS, which is amyotrophic lateral sclerosis, and the incidence of that disease is claimed to be 1 in 300 people will be affected. So that's a lot, So when you put these numbers in your head, it means that if there are so many widespread diseases concerning brain, it's very little that we have understood, and there's a long path. I would not say that we have not started. Yes, we have definitely started, but it's a long road ahead to understand how the brain works, and then only we will get to know what happens in the diseased situation. So for that, we need to know how a healthy brain works, how we age, and most of these are aging related disorders, and then we'll understand what exactly goes wrong when we age but we get the disease. So it's to keep it in a very layman's term.
Right.
So there's a long way to go, but yes, the good thing is we have made a start, and I'm very hopeful that we will crack this.
So if major brain problems or diseases which you're working on is ALS, Parkinson's,
Yes,
right? And you would like to touch upon few major, these days we see or encounter this related to brain.
Yeah. So one of the other umbrella term that you would, I think, hear a lot about is dementia.
Yeah.
So dementia is something that will impact people like anything. I mean, there are projections. If you look up WHO websites, there are projections that it'll affect us immensely. So something that has been started. I mean, in the West, there are like so many labs, so many pharmaceutical companies who have started this process. So, but as I said, it's a long way. It's a long way from now. To understand this diseases, why they develop, when they develop, and how best we can intervene. So these 3 questions, they are something which will lead us. But yeah, we are on the right track, but it's a long way.
Okay, so I'll try to, because if most of my audience are young people and even common people.
Right.
The idea here is I try to cater science in a very simple format which they can implement in their daily life.
Of course,
right?
That's very nice.
So with that mindset, if I say dementia, how do you explain dementia?
Look, dementia, as I said, it's an umbrella term. It can, in a layman's term, it can be, you have seen like aged people at home, they often forget.
Yeah.
So there's something related to their memory. So if you think about, there's a disease called Alzheimer's disease, which is the commonest form of dementia. People forget. So the part of the brain that is responsible for your memory, that part of the brain becomes dysfunctional. So then you forget. The other dementia is when you have, there are this few of the movement disorders. For example, Parkinson's. You often see that the hand trembling, or there are hand shivers. So those diseases also come under the umbrella term, dementia.
Okay.
And then you have sleeplessness. So people often get up from their sleep at night. So they are some of the clinical features of how you would use the term dementia. Again, dementia is an umbrella term. It encompasses all these clinical features that
Correct.
you might get sleeplessness, you might get memory dysfunction, you might have a problem in your motor symptoms. So that's how you would in your audience, I think, you can coin dementia as.
No, that's well put
Yeah.
into. Dementia, I think, with the current generation, the stress and the mental health is something which is
Yeah.
much talked about,
Yeah,
right?
yeah.
And from that perspective, all the dementia or whatever, Parkinson's, Alzheimer's,
Yeah.
what falls under the umbrella of dementia, are they only age related, or can they happen early on also?
No, you are absolutely right. I mean, I really thank you for asking me this question. In Parkinson's, the disease that I'm very interested in to study, there are cases of early onset Parkinsonism. It's called EOPD, a very commonly used term, wherein the onset, previously, as you said, Parkinson's was like an aging related disorder.
Right.
So generally we would see people affected in the age of 60s, 70s or something. But now, we don't know why. Now, this is the biggest question. We see a lot of early onset Parkinson's cases wherein people get the disease in their 50s, late 40s. Yeah, and so and out of interest, I must share this, that in India there are many early onset Parkinson's cases. We don't know why. So the onset is way early. In Indian cases, few of them. And there is this another form of Parkinson's disease which is called juvenile Parkinson's disease. The onset is even earlier than 40 years old.
Okay.
Yeah, so they are called juvenile Parkinson's. So, it's like we don't know why. I think that is one of the reasons why I am here. So we don't know why the disease take place, like the onset is so early. But yeah, so these are the questions, if we stratify the diseases according to these age of onset or something, there are a lot of unanswered questions. So that's where I think the future research is going to chip in.
Correct. So, see, most people think brain is completely isolated from the rest of the body. It's a very sophisticated organ in a very secured skull. It is there. But your work shows that our immune system, the cells that are fighting even common colds,
Right.
they can actually affect your brain.
Yeah.
And can you explain on this?
Of course, I mean that's very, very good question. You've done a lot of background. I'm very happy for that. So in brain, it is isolated absolutely. So it's something which is very, very isolated from other part of your body. But brain has an immune system of its own, and you have these immune cells of the brain. They are called, maybe I will popularize the name of the cell here, it's called microglia. So they are called, they are the immune cell types of the brain. And so imagine your brain getting infection or any other clearance that your brain might need. So these microglia, they act as a policeman in your brain. So whenever things are going wrong, they will go and try to address that. Say, for example, you have an odd deposition in your brain where there are these aggregates or something. So microglia will go, they will gobble that thing up. They are called the phago. They have in technical terms, we say they can phagocytose. So they will go take that protein and they will eat it up. They will digest this. And then if you say, for example, you have an infection or you want to fight a bacterial infection, so they will start producing cytokines. So they do all these housekeeping jobs. So if you coin them as an odd term, when you have to stop inflammation, well, it's not something that you would do because they are taking care of your brain. But now if I dial it down to the diseased context, now what happens is the inflammation, you need the inflammation for the healthy brain, but you also need that inflammation to dial down when everything is fine. So once you address all these isolated incidents, so the microglia responds to it. Now when those challenges or those insults are gone, you need to dial it down. So microglia dials down. But in diseased context, what happens is the microglia remains active throughout, or your immune system remains active. So that dialing down of your inflammation, that doesn't take place.
Okay.
So you cannot coin them as the inflammation or these cells as villain, but probably it's the dysfunction of these cells that makes your brain microenvironment very, very inflammatory. And that is a common chord, or that is more like a common denominator that you find across all your neurodegenerative diseases.
And what are the factors which actually regulates or dials them down?
Very, very good question. So there is this biological mechanism which is called autophagy. So in common terms, it says it's mostly cleaning up your cellular system. So whatever these cytokines or these odd inflammatory mediators which are there, so if once your cell has lot of those inflammatory mediators, the cell itself can sense. Think about a cell. So cell itself can sense, oh, this is going quite high, I don't need them. So your autophagy, that gets activated. It cleanses your inflammatory mediators from the cell. Now in diseased context, what happens is that autophagy, that mechanism, that becomes dysfunctional. So those mediators are not cleaned up from your cell. And that is why the cell keeps producing those cytokines. Now I think everyone knows what cytokines are after COVID. So the cell keeps on churning out cytokines because there is nothing to regulate them or to instruct the cell that you don't need to do that. So those mechanisms, they become dysfunctional and they kind of contribute to the disease.
Wow.
So the entire concept of having inflammation as a villain, yes, it is the villain, but probably stopping that time from the very beginning is not the answer. So you need to target those molecular mechanisms that regulates inflammation.
Okay.
Not bluntly stop inflammation from the very
beginning.
Yeah.
Okay, that makes sense. That makes sense because initially that is required.
Right.
But after the job is done, they need to dial down.
Yeah.
And that is not being happening.
Exactly.
Right?
Yeah.
If I've understood.
Yeah, absolutely. You're right.
Okay.
Yeah.
Okay. So, we'll go back again to Parkinson's.
Of course.
So, like, you are trying to solve the mystery of why some people get early onset of Parkinson's disease, and the age group is somewhere around 40s or even less than that.
Early onset. Early onset is around 40s to 50s, and beyond 50s they are categorized at late onset Parkinson's disease.
So, which country is at higher risk, and where is the position of Indian population?
There is, Indian subcontinent, there are a lot of cases wherein you get early onset Parkinsonism. There are published literature on that. Okay. So, and another interesting thing is the genetics. So there is, in early onset Parkinson's disease, this majority of the cases, they are genetics. So what I mean by genetics is if you have a particular mutation that can cause is a big word, so that can cause your Parkinson's disease. So my aim is to do in my lab is to look at the genetics of the early onset Parkinson's disease population in Indian context. So because you have to imagine that, that also brings to the question why I am back in India, because I would want to, India is, as we all know, it houses 1/5 of the global population. And that's absolutely underrepresented. If you think about the global signature, when we analyze global signature of any disease, there is hardly any data set which is coming from the Indian population. And
Is it?
Yeah, so it's highly underrepresented. And given that you have Indian origin people migrating from India to different parts of the world, I think it's of global importance that we understand the genetics, or we study Indian people, because that's something which is important, and as I said, it's of global importance. So that's one of the reasons why I came back from UK after 8 years to study these diseases in the context of Indian people, because the genetics is different, our lifestyle is different. Unfortunately, the pollution that we are in, it's in a different scale.
Yeah.
So the food that we eat is different.
Yeah.
Our food habit is different. So we need to, factor in these differences and then perhaps study Indian population. So as coming back to
when you're talking of Indian population, to limited of my knowledge, because sometime back I did a podcast with Professor Thanguraj. So we have a very interesting admixture population in India, and ethnicity is also root backs to different ancestry.
Absolutely.
Now, coming from that perspective, is it more challenging in terms of establishing your factor genetically for population or the entire country as well as the regional cohorts?
If you think about our country, I sometimes feel this is like a mini Europe, because you have diversity like anything. Like it's not north, south, east, west. It's way more diverse than that. And coming back to your question, that whether these will all have an implication when I study genetics, the answer is yes, it will have. Now we don't know, and it's not only about genetics, it's also about where they have been staying. So there will be something, there will be more of an epigenetic changes taking place in part of your genome, where someone coming from, say, up north, where there is very, very less pollution, we don't know how their genetic makeup and what is contributing to it. So it is a complex study, but I think we need to start somewhere. So we'll start and then probably stratify, as you were saying, because our country is diverse. So probably we need to look at those pockets of people who are coming. Again, the ancestors could be mixed. So these are all of the I would not say challenges, but they are more like an opportunity wherein you can study Indian population better.
Totally agree with you. Totally agree with you. So, when coming to genetics only, because already we have touched that point.
Sure.
So, looking at Indian genetic background, especially so critical for research, do you still believe, like that's what you said, you moved from Europe to India, on that ground, that in Indian population will be able to work, right? So, if you see the compare basically with Europe, compare with United States or other parts of the globe, what advantages do you think India holds in terms of genetic studies? Partly you already mentioned.
So it's mostly about the diversity, and you need to understand, like as I was giving an example, early onset Parkinson's disease cases, they are quite high in India. Do we know the answer to that? We don't know. Do we know now? If you look a little deeper, the drugs that are being proposed, or they're in clinical trials, or even when they're in the market, how many of those drugs have been tried on Indian population? It's 1/5, right, of the world population that we have, but there is not many. So we don't know whether a drug which is working on a Caucasian population, say for example, will it have similar kind of impact on Indian population? So we don't know. Probably there will be no change. Probably it will be similar, equivalent, but we still don't know
but the efficacy might be different.
Exactly. Efficacy, dose, your time, what is the time that you would be able to?
True.
Nothing.
True.
So these are some of the very open-ended thing, and trust me, Somenath, it's not, I will not be able to answer it, or whoever scientist at my level will not be able to answer it in 2 years. It's gonna take time. So it's it's quite a long road ahead. But yeah, I hope that I've been able to, I would try to make a start at least, you know.
Oh, that's important.
But these are the open questions that, because you remember that the drugs that you are giving to your patient, that patient will have a completely different eating habits, different lifestyle. They will be exposed, as I was telling, different air quality.
Yep.
So all these are confounding factors, and we do need to factor them in.
True.
So let's see where
genetics, epigenetics, everything comes into picture, and how much of that slice do we know?
Yeah.
It's a big question.
It's a big question.
Right. I agree. No, somehow, no. If we can see our discussions, we started with brain, the Parkinson disease or dementia, and then somehow we also tried to find out whether genetically Parkinson disease can be traced back.
Right.
So if I say in a very simple word, is a family having a genetic history of Parkinson's, is it very likely that in their future generations they might develop?
This was exactly what I was reading up today. So it's good that you asked me. So, you know, there's a word that we use when we talk about mutation, is the penetrance of that particular mutation. So if I have the mutation, say for example, am I like 100% sure I will get the disease? The answer to that is no. Yeah. So the penetrance can vary from one mutation to the other. So it's at the moment, we don't know answer to that if I have the mutation, will I get the disease 100%? No, we don't know that, because there are these families, you know, two siblings carrying the same mutation. One gets the disease, the other one doesn't. So there is a lot of, so there are two takeaways from here. One, if you carry the mutation, it's not that you will get the disease, or you will get the disease at the same time. Say, for example, one of the sibling is getting the disease at 50 years. The other sibling is like, okay, fine, I'm 50 years now, so the disease, there will be an onset. No, it's definitely not the case. The other takeaway is, say, for example, the other sibling who has the mutation did not get the disease. We would like to know why. Because there could be some neuroprotective pathways, or few protective pathways that is enabling that sibling not to get the disease. So if you think about these stratifications in your head, like clinically meaningful stratification, there's so many things for us to understand that why.
I have an interesting question. Just it comes to my mind is, suppose that person is good at chess and he does a lot of brain puzzle activities. And despite having the mutation, that person is not developing symptoms. Is it possible?
I mean, it is not even possible, it is happening. So and I don't know your relevance. I understand what you're trying to mean when you say chess. It's like your brain is making your brain active. But I mean, we don't know answer to that, to be honest. I mean, there are these stratifications if you make. Say, for example, I had worked on the disease ALS. There's so many rugby players who gets affected with ALS. Now, do we know the reason to that? No, but we know a correlate. So in this Parkinson's case, we have to see whether doing some creative activity, say, for example, does it have anything to do, or it is simply a coincidence? So there are many studies that can, come up from these kinds of observation. So probably on that line, I must say that scientist and clinician, if they come together, there cannot be a better ecosystem than that.
Yeah, agreed. I always feel whenever there is a disease, a pathway, or even a human body, how it manifests different symptoms, there has to be a very good collaboration between a researcher and a clinician.
Yes.
And if this collaboration is not there, I think there's a huge gap.
Huge gap. So you cannot work in silos, or you cannot work in isolation, because at the end of the day, we are here to do translationally significant science, which will have an impact on the society.
Right.
So that is very, very important for any scientist. I'm sure that we do not work in silos. We do not work in an isolated ecosystem dealing with only ourselves in the lab. We are here to make an impact on the society, and the way to do that is our approach. So we would need is the word. It's a hard word, but we would need clinicians to work with the scientist, and that's the way forward, I think.
Yeah. I totally concur with your thoughts. Now the question is two aspects. One is most of the area is gray. We are still trying to put the puzzle into it and make a complete picture. In that scenario, if I am if I have, maybe I know my ancestry who have a genetic a presence of or the mutation, and I might likely develop dementia in future, or another scenario, I do not have any genetic history, and in both the cases, how a person should try to see. One thing is whether it is mutation, it will express or not because of various factors. How much do we know? That's a big question, right? But as an individual, what can we do to prevent ourselves from any of sort of this type of diseases?
Again, the answer to that, we don't know yet completely. But there are few studies that are suggestive of changing our lifestyle, for example, a little bit. For example, gut microbiome plays a very important role. We don't know whether it is causal or contributory.
Okay.
Yeah, but we see an association, if I put this word correctly. So the association of gut microbiome dysfunction is something which corroborates with the disease. So probably something which we eat can have an influence. Pollution can have an influence. But the silver lining, I don't know for everybody, but for me it is the exercise. So there are multiple changes that you can make. You can have the exercise as you go to gym, or you go for a run, or go for a walk, but devote some time for doing these activities. And in that way you can think, okay, fair enough, you are doing your bit, but we still don't know the answer to that, whether what can I do to prevent dementia. I don't think anyone can come up with the answer at the moment. But as I said, it's a long way. Probably we'll see in what happens in 20 years time.
Yeah, sure. We need to find out.
We need to.
This is, as I said right at the beginning, this is an untreaded path.
Absolutely.
And there are lots to work on, and I think that's the need of the
That's
art.
Yeah.
So, okay, now a little bit changing on to the direction of our discussion.
Sure.
Is we will be interested to know that, little bit about your academic journey and how, as you rightly said, that, your brain is something, a fascinating organ, and that somehow touched your heart and you started working on it, right?
Yeah.
But what was the first, did you recall, when you thought of, yes, this is my area where I should be working?
I think I would say it is a process. It's not one particular day, or it's not that dramatic, Somenath. It's a process. So I did not, wake up, as I was saying. I mean, that, neuroscience is my way forward. No, I think it's a process. It was a process which involved my curiosity and, of course, my reading and my interest on human brain. So
you had any seniors working on this area, or you saw somebody
I would say no. I mean, I did not have a goalpost that time.
Okay.
It was very natural way of doing things. It was about questions I had in my mind, that how does the human brain work, and importantly why it fails at times when it comes to diseases.
Yeah.
And trust me, I still have that question in my head. That's a constant thread. That's a common denominator from, if you think like day one to now, why the human brain acts differently when someone gets the disease.
Yeah.
So that's my constant curiosity in my mind.
Okay. Okay. Almost 8 years you spent in UK.
Yeah.
Right. And then I know now I have the reason why you came back to India, right? Now, what was difference in terms of academic exposure, Indian setup, research setup, and UK research setup?
Yeah, I think that's a good question. I think so. UK is very, very organized, I would say. Like, they have a fantastic health service, NHS. And they have a beautiful blend of clinicians and scientists working together.
Yeah.
So that was the ecosystem, as I was telling you like few minutes ago about how clinicians should work with the scientist. So this is something that I have learned from Edinburgh, where I did my postdoc from. So it's a beautiful blend. We know that we could run to a clinician anytime and say, hey, this is what I'm seeing in the dish. What is happening to what has happened to the patient? So that blend is something that I am incredibly grateful to my mentors. So my supervisor was a clinician, and we got the essence of how a research or a translationally significant research ecosystem should work. That's something I have learned from UK. No questions asked on that. And the other thing, I think you were trying to ask me why I came back.
Yeah, that partly I think
I have answered, but I think I'd add on to that where I feel that you have learned something back in the West, and there is an opportunity where you can contribute more, which is where I currently work, Scan Research Trust. They are trying to develop an institute which is aimed at aging and neurology. So I think that this is a wonderful ecosystem wherein I can contribute whatever I have learned back in the West. And of course, my other interest, as I was saying, it's to understand Indian population.
Most of the people who are almost in their final years of their submission in PhD, they have a very common question. Should I go for a postdoc or should I abroad specifically, and or should I continue in India, look for a job? So what is your take on that?
Look, if I look down the memory lane again, it will be, I did a postdoc because I had this constant curiosity in my mind and to learn how a research ecosystem exists outside my country. My PhD was from India. So if someone is interested, they have a research question in mind, then I think they are best suited to deconvolute what is that they want to do. So if they have a constant research question in their head that yes, I need to understand more and more and more, dig deeper, then probably they can pursue a postdoc. But you also have to understand that pursuing any postdoc is not going to answer those questions. It has to be very tailored, or you have to select the lab or what the lab is working on that has to align with your interests. That's very important. Simply doing a postdoc doesn't mean anything.
True.
Yeah, and there are other subpopulation whom I have seen, brilliant people. They want to contribute to pharma, say for example, which is great, because at the end of the day, if Eli Lilly has a drug, it's contributing to the society, So, and someone wants to contribute to that process. Fair enough. I mean, it depends on the interest of the particular individual and the clarity in their head.
True. Fairly put onto it. And I think exposure in different formats are important.
Yeah.
Obviously, when you're doing your PhD, you get some sort of exposure
Yeah.
in country. But I still feel exposure at an international level gives you, widens your horizon.
Absolutely.
You get a different perspective.
Absolutely.
And then you choose your path, how to move ahead.
You know how different things are between one country to the other, but one thing remains constant is your curious mind.
Yeah, that's true.
So that's something which goes without saying. So
True.
But there are many people who have done, like, say for example, not like me, I've done my PhD in India, but there are other people who have done their PhD abroad. Now the question remains the same: should I go for a postdoc or should I go for an industry?
Yeah.
So
That's a different aspect.
Yeah.
But again, doing PhD in India or doing PhD abroad?
I think PhD in India,
Right.
you start your journey from the scratch, and that teaches you so many things. I any day, if you ask me, PhD, I mean, again abroad, it's fine, it's great. You learn this newer technologies, and then you are exposed to a different world of technical expertise, and majorly it also depends on the lab where you are working on. But in India, the denominator that I have seen with my limited experience is you start from scratch, and you learn a lot of things. Probably I am biased because I am an Indian PhD student.
No, that's okay. This platform is for sharing your views, right? And unfiltered views are what welcome.
Well, so you welcome them.
Yeah, great, nice. Many young students, especially the young women students, they are looking for different fellowships. They are looking for, like nowadays, STEM is something which is highly you can say the center focus point, and people are Government of India as well as everybody is focusing onto that. Now you recently got IBRO Rising Star Award. Congratulations for that.
Thank you.
Now, first two questions I have. First one is, when you came to know about this award, what was your first reaction?
I'll be completely honest with you. These awards are funny. We only look at the bright side when we think about these awards. But I actually remembered the amount of roadblocks that I had, like how many failed experiments I have done in my life, how many hypotheses were there which have not been, which were proven to be false. So as I said, it's a journey. It's good to see the silver lining at the end. But I was the feeling that coming back to your question, the feeling that I was feeling very grateful to all my mentors, my supervisors in particular. I had a lot of them, and everyone were like so helpful in this journey. So I felt very grateful.
Wonderful. And the second part of the question was, yes, obviously getting this prestigious award and being a role model for most of the people who are upcoming into the research.
Sure.
What one thing they could do right now, and that can change their trajectory? What is your advice to them?
I somehow think they should keep asking questions. They should see the world, know what is happening in your area. It's not only neuroscience, it can be anything, so they should know about their world, and they should understand, in our terms we say knowledge gaps. So they should understand this is perhaps which is missing, kind of a missing chunk in the puzzle. So sooner you identify that, you start asking the right questions. Once you start asking the right questions, that will open up that window. Either you get in touch with the labs who are working on them, be a volunteer, go to a lab and say, hey, I'm interested in this. Can I just be a part of your lab for a few months? Do internships. So these are the things that can change, actually, that and interact with people. So moment you come into this ecosystem, and then you get to interact with scientists, and that can enable you, about thinking.
In form of like networking?
Networking is a term that we use at the moment, but if I think you are talking about like
scientific networking.
Yeah, networking, that is what we use. Say, for example, if I sit with a fellow scientist, that will be more of a networking. But here,
from the student level,
from the student level, I don't think. They don't need to network. They need to voice out their questions, and perhaps that will enable a scientist to identify them, because their challenge at that level is to make yourself a bit identifiable and then ask the right questions, or identify the right questions rather.
On this note, so in India, if I talk of Indian perspective, there are premier institutes in top-notch cities. There are also institutes in tier 2, tier 3 cities as well. Right? Now, two scenario, one person from a tier 1 city with all the connections and maybe the head offices, like for example Delhi, all the head offices are sitting there. That person can simply go to the offices, make contacts. Now another person, tier 3, how should they capitalize this approach and make like approaches different labs? And what are your suggestions to them?
Right, that's very good question. So as you are right, people coming from the city or tier 1 city, things are there around them. They can rightly go and barge into a lab, say for example, and they would know the tricks to do that as well. But tier 2 cities, but I think they have to think out of their box, because at present day and age, it's not like how we were there. So it's like everyone has got internet in their mobile, right? At least many of them. So probably they need to walk an extra mile and maybe write to the scientist that, look, I'm from this and this. This is the question that I'm having. I'm very, very interested in doing this. I saw your lab is working on this. Do you mind if I have a quick chat with you? Because nowadays having a chat is nothing that we did not have back in 1990s, that era. So I think many scientists will welcome them. I don't think any scientist will say, oh, I don't want to talk to you, because I think those days are gone.
Agreed. These days, more and more people are socializable. More people are vocal on social media platforms.
Absolutely.
So this is a wonderful point.
You can email. At the max, and I don't think people need to get bogged down by the idea that, oh, I'm from a tier 2 city or tier 3 cities. Email doesn't discriminate, right? So you can email. You have the internet in front of you. So get the email ID, write to that particular scientist. So it doesn't matter. So today is a different day and age. If you see what I mean, like when I compare back to when we were studying.
Even I would just correlate this part. See, when even in our time also, people who used to try for postdoc, they've never met those people or the PIs sitting in abroad. So what we used to do is in a day, maybe 100 emails.
Absolutely.
And we used to say, okay, fine, understand, read, prepare your statement of purpose, and then customize your email for sure. But yes, you can shoot as many emails as possible, and your chances of acceptance gradually increases.
More, you have to try. That's what I said. You have to walk that extra mile. So we read about their work, and first of all, it's very important to have a clarity in your head that this is what I want to do. And that's why get awareness of your field. That's very important.
That's where I think mentor-mentee program or relationships comes very important, right?
It can be.
Great. So again, we will be just touching base onto something for the upcoming young minds. Okay.
Sure.
So from that perspective, if a group of students from college, they all of a sudden enter your lab, what exciting things they can expect?
They they will see people are working. But I somehow feel, given that you asked me this question, it's not the equipment that makes a lab. Yeah. You would see people being bombarded with questions. People identify anything different all the time. So I would think that if they come to my lab, they will see people probably thinking and asking questions and probably doing some experiments to see whether whatever they are thinking is right or not right, or something different. So you will see a beautiful scientific cookery, I would say.
Yeah.
So so yeah, as I said, it's not equipments that make up a lab. It's your ideas, your curiosity.
What do you feel? A person who wants to pursue research, is it important to ask questions?
That's the thing that gets started. If you don't have questions in your mind, if you don't have curiosity in your mind, then I think it's difficult to do science. So you have to the awareness of the field and identifying your gaps, asking the right questions, and then executing, or then finding out techniques that will align or answer your questions. So this is all what we do.
Yeah.
So
and searching again and again is research.
Searching again and again is research, as the word says. You are right.
Okay. So what should I learn in college that nobody tells you about?
Communication is the key.
Wow. Yeah.
You must learn how to communicate. Today is a day of show and tell. So you got to communicate what you are thinking. And even when you ask questions, or when you present your data, or even though not your data, present your interest for that matter, you got to communicate it. That's something which I think anyone can start. As early as you start, better it is.
But in schools, do they teach communication?
Probably they should have a curriculum. I'm not really aware of the school curriculum at the moment, but something which is a part and parcel. This is the day of show and tell. So you got to learn how to communicate your thoughts.
Do I need to do a PhD to do a meaningful research?
I don't think so, because PhD is it's a road that you are on. It's a path. And you want to contribute at the end of the path. It's your contribution to the society, your impact to the society. PhD is only one of the way to go to achieve the goal. So, and nowadays there are data scientists who are there, who does a lot of analysis of this big data, and so there you don't require PhD. So it depends on your interest. I would say degrees, please don't consider degrees as trophies. It's more how would you want to achieve your goal. So PhD is not mandatory at all. Your expertise, your skill set, those are important.
Very well put on. I think that's important. That's important to understand, because I don't think there is any lengthier degree than a PhD.
I know.
And you need a lot of perseverance, patience.
Yes.
Every day, I think, you touched one point, is like your successes might be one or two which you can count, but your failures are like every day almost.
Yeah, absolutely. I mean, you have brilliantly put it, because we have lost counts how many experiments or how many hypotheses have failed.
But the courage that every second day I'll come with my head high, and with that same positivity that today, no matter I'll fail, might be 99 times, but there's a chance that in the 100th step I might succeed.
You might. So this requires a lot of resilience, is the word. It requires resilience, but I would not say it is, PhD is mandatory, given your whatever your goal set is. You can do multiple things, but your main thing should be you should be able to contribute. So if that is the case, then and PhD is a journey. So there will be success, there will be failures, probably more failures. So this is a saga, but it's very rewarding at the end. I must say that.
If you were starting your research today, would you still pick neuroscience?
I think I will, because as I said in the beginning of your show, I was very intrigued with how human brain works. So that is still there. I told you in the beginning as well. That's the question that I started with. And I'm still following that question. And we have learned a lot of things, like going abroad, learning multiple techniques, multiple ways to address this question. But it will go on, I think. But yes, if I start any time, if you take me back to the memory lane, probably I will still follow my quest.
I always remind this question always reminds me of Professor Lapotia. So I was doing a podcast with him. He spent good 40 years and still he is active into research. I asked him the same question, that would you still do it if you get one more lifetime? And he said happily, without a doubt. Without a doubt.
Absolutely.
And for answering that question, he didn't even take a second to think. He was like spontaneously, yes, if I get one more lifetime, I would love to do this. Imagine a person who has dedicated so long in a particular field and feels so enthusiastic about his work, about his research. Amazing.
And that's how passionate we are, It's like even budding scientists like us. So every day you feel that yes, this is something which we don't know. So that's the drive we get. So and this is for everybody. If you do not have that this drive is a bit unique. You have failed yesterday, but today, as you was mentioning, you wake up and you're like, yes, I'm just going to do it. That's your drive. And unless and until you have an intrinsic curiosity to follow it, it's tough.
It's tough. Yeah. Okay. Is science in India even viable for young people, or they are comparing either a passion versus paycheck?
If you want to become wealthy, academia is not the one. Like if you're given that you hinted upon the fact of paycheck, no. But where it makes a difference is the impact that you make in the society in the long run. So say you start off a clinical trial, or you find something exceptionally interesting which could be taken forward, which can have an impact on the society. It's the scientist who has I would say there is a lot of possibility in there. So if you want to make an impact, yes, academia is the one. But if you want to simply, want to earn a paycheck, which is fine, then probably academia is not the one.
Right. Okay. Why most Indian researchers prefer to go abroad?
I think it's the ecosystem. It's the ecosystem. It's excellent there. But people like us also come back.
True.
I think it's overall, where it's fine. You learn something, you see what's the best and how better it can go. But you will also have to think, I was telling you before, where you can make your maximum contribution. So probably if you come back to your country and there are a lot of scopes and opportunity where you feel that yes, I can contribute. So possibly there is a bit of reasoning there. So you can develop your comfort zone, you can stay there. But if you ask yourself, am I contributing to my fullest? Then probably you might get a different answer. But again, that's very individualistic. So it's great outside. It's a research ecosystem, which is brilliant.
Yeah, true. What's something about your research that funding committees don't understand?
This is a great question, and the answer can be very long. But to when we go to the funding agency and when we come up with a research question, it's not very straightforward every time, and it is quite a gray area because you don't know. As I said, hypotheses fail every other day. So imagine you are asking to your funder, give me money for my hypothesis. It's just very, very different, very opposing. But yeah, I mean, these things happen. Your funds get rejected all the time. Like a majority of the time, we will see our grant application has been rejected.
Yeah.
But yeah, I mean, I think that's there across the globe. I would not say this is very intrinsic to a particular geography or something. But I think they need to understand that you need to take some risks and allow others to take some risks. It's not always a very straightforward journey. But, it's a part and parcel of our life. We can make a huge hue and cry out of that, or simply just say, okay, fair enough, move on.
Fair enough, move on.
Yeah.
Yeah. Okay. So I maybe the last point is are you actually hopeful about the ALS treatments in another decade?
Yeah, I mean, ALS is something, a little bit, I'll tell you on ALS. ALS is a very progressive disorder. So, often patients sadly dies within 3 years of their diagnosis. That's hugely rapidly progressing disorder. So I think people are coming up with novel angles of research. Like previously it was perceived, I think it's not for ALS, you can generalize it to any neurodegenerative disease. Even when I started looking into brain cells, it's the neurons that die. Everyone, that is the reason why it is called neurodegenerative disease.
Yeah.
It's the neurons. In Parkinson's disease, the midbrain neurons, they degenerate. In Alzheimer's, there are these few areas of your memory, areas of the brain that define the memory problems, they die. In ALS, your motor neurons die, which is the neurons that stay in your spinal cord. So they die. So people in the even 10-15 years ago, they were concentrating on the fact that let's have a very neuron focused program. Let's allow the neurons to live. But now we have understood that neurons don't work in isolation. Your brain has many different kinds of cells, and one of the major cell type in your brain are the glial cells. So if the glial cells, the dysfunction, which is meant to provide trophic support to your neurons, if they go south, your brain or the neurons, they don't survive. So a lot of these things, they have come into the picture. It's like from the field being absolutely neuron centric to people have started, like people like me, microglia is one of the glial cells wherein we are talking about immune system. So people have started decentralizing their focus from the neurons to other cell types of the brain. It has been hugely acknowledged in the fields now that neuronal degeneration might not be a cell autonomous problem. Yeah, so it can be contributed by other cell types. So this is one of the newer approaches in the field of, not only in the field of ALS, but several other diseases.
If I've understood properly, glial cells are basically housekeeping cells?
Yes, they provide, like say for example, you have astrocytes, which is a kind of glial cells. You have oligodendrocytes, the myelin sheath that circles around your axon. So there are oligodendrocytes. There are microglia, which is the immune cell type of your brain. And there are multiple other kinds of precursors at times, although very, very less proportion, but they are also present. So you have to think that this is not a super new concept, but it has been increasingly acknowledged by the society that none of these cell types, they work in silos. And they all work together, and dysfunction in any of the cell type can result in in a imbalance in your brain.
Okay.
So these are the newer approaches. People are becoming familiarized to it. People are researching on it. So newer drug trials. So when you do an in vitro drug assay, it's not only the neuronal cells. There can be other cell types that you also need to factor those in. There are functions that are tied to these cells. So there are multiple stratifications are coming in place, not only to ALS but other diseases. So we hope that these newer approaches will enable to identify kind of therapeutics, or probably you might not address one cell type, but you address all the cell types. So very multi combinatorial drugs can come into the picture. So these are the newer concepts. I think we are on the right track. I would like to think, but let's see where we go.
Okay, I have a similar question on this topic only. We usually have habits, right? And when something we do repeatedly for years and years, that particular action, the neurons have become joined profoundly, and that has become almost like a fixed wire.
Right.
Now today, I think tomorrow, I want to take a resolution. Tomorrow onwards, I want to start one good habit. Right? And it is like making a new connection. Right? Is there any hack to do that?
There is absolutely no hack. It's all how how you think. So the part of the brain that enables you to think, and it's all communication of one cell type to the other. But there is no.
But there are a lot of people who talks about brain rewiring. Do you believe in that?
It's a very vague term. So let's not go into that. There is no hack. So. There's something that your brain cells talk to each other, and of course, if you want to develop a good habit, please go ahead, develop a good habit. If you think that you want to quit some bad habit, please do it as soon as possible. So that's your hack. Your hack is there in your thinking.
That should be the mantra of life.
I know.
Okay, coming to habits. Which one habit that changed your career?
Yes. When I started my research journey, when I started working in habit, I used to work really, really hard, like very hard. But then once you go down this road of PhD postdoc, and then you're setting up your lab, it's not working hard, super hard. Obviously, you need to work hard. That helps. But at the same time, you need to take a pause and probably think and introspect. So that is something which is key, I guess. So you learn that with time. It will not come in one day. Again, as I said from the beginning, it's a process. So you learn to take a pause and introspect, and then probably again go back to your routine. So I think that is very, very interesting, and that has helped me a lot.
Interesting. I'll also try to do that. Okay, what do you do when you run out of hope? And why I'm coming to this question is, in a life of a researcher, I think hope runs out at times.
Yes, but that's where resilience chips in.
What is your mantra for dealing with it?
I think, again, it's a process. So we don't really lose hope completely. Yes, there will be puzzles. There will be roadblocks. But you again go back to the drawing board and perhaps figure out what is that went wrong. It's not even wrong, You probably need to have a different perspective, maybe a different approach. So it's never like lose hope completely, but yes, you need to be very realistic about it. That yes, something is not working. Fair enough. You go back to the drawing board. I can read up literature, because now there is no dearth of that, and then you come up with altered approaches and think differently. So
true. With the hope, I usually, some time back I was reading, there is a theory called missing tile theory. You are aware?
Yeah.
You've heard of it, right?
I've heard of it.
So there's a story like one person built a beautiful hotel, perfect hotel in all possible ways, and in the entire hotel, in the swimming pool, he deliberately misplaced or changed one tile.
Yeah.
So he invited all the guests,
Right.
and then he started taking reviews when they started leaving the premises. And everybody gave a, like, it's every good, but that tile is wrongly placed. There's one tile wrongly placed. So the concept goes like this, that it's how are we wired to look into.
Yeah. Probably you can say that, but as a scientist, there are so many failures in our experiments that it's fine. You're programmed, at this stage.
Yes.
You're programmed not to lose hope completely.
Correct. And in fact, we are also, like, as a scientist, I've seen you give a sheet of a paragraph written on it, and I feel all the scientists have developed this knack over a period of time. They immediately see it and point out there's a problem, there's a apostrophe, there is a comma, this is tense is wrong. So are they designed to look critically and find faults?
That is there. That is something that you develop. Yeah.
Right?
You have a tendency to look things at a very different, altered resolution, to be honest. That's kind of part of the job kind of thing.
Yeah. You develop it as you are in that job.
It doesn't come. As I said, it is 15 years back. No, but again, I don't know how I'll become 15 years down the lane. But I think, it comes with the critical level of thing that comes with the job.
Yeah. So what's something you believe 5 years ago and that completely changed your perspective?
Good question, Somenath. I think probably 5 years ago, the concept of collaboration or working with multiple people, that was not there. But now we have understood that no one, as I was saying, none of the cells work in silos. Even scientists cannot work in silos. So you would need complementary people who can support you for your overarching goal. So I think finding collaborations or working in collaboration is something that is different now. So that's a novel concept, not a novel, probably novel for me, but it's a very helpful concept that I have picked up, and especially again because of my postdoctoral experience back in the UK, everything is very, very collaborative in nature. There's nothing like this is mine, this is yours, I will work isolated, you work your work. No. So as I was mentioning, like clinician and scientist, they work together. Say, for example, my expertise is stem cells. My expertise is not proteomics. So the quickest way for me to get a proteomic study done is to collaborate with a person who is, bread and butter is LCMS.
Correct.
So, like mass spec person. So, and there is nothing, this beautiful harmony in that. So that's, the collaboration is something that I think was very helpful.
Yeah. True,
there is
true.
on that I just remember there is a saying that goes that if you want to, I'm maybe misquoting it, but the theme will remain the same. So if you want to walk fast, walk alone, but if you want to go far, go together.
Yeah.
So that's something that really comes in my mind.
Yeah.
The very essence of having a collaborative
That's I think,
ecosystem.
Yeah, that's very pertinent.
That's
and
good.
it's not pertinent in field of research. I think it's pertinent in every aspect.
Maybe, yeah.
Because as a community, we thrive better than individuals.
Absolutely.
Right? And community means in society, if you see, and in industry, in corporate, in every sector.
Yeah.
I think this is a wonderful line. I am taking it back today.
Collaboration is something that's really a good thing that I have picked up.
Right. So, sleep or work? What works as a real balance for you?
I think sleep. I mean, neuroscientist. It's always sleep.
Taken. Degree or skills? What matters more?
As I said, degrees are all about, if someone considers degree as trophies, I'll go for skills.
But with AI coming aggressively, skills can be replaceable?
I don't think. I think AI is fantastic. It is going to make genuine contribution, not only in science, but everywhere. But, there is something, again, this is my take. You need a human frame of mind to think. And AI can give you answers to the questions that already exist. But what are those questions? Any new questions? So there, I think you need human brain.
Yeah.
So AI is great in layman's term, great in analyzing the data or make fantastic correlations, but it can only give you answers to the questions that you ask it to give. But coming up with new questions or identifying what is that you would like, identifying gaps. So that, I think it's still human. You need a human brain to do that. Now again, this is my take.
Right. Even the next question, I know the answer from your side, but still, PhD India and abroad.
Maybe I'm biased. India.
India, I know that's well. Postdoc, India or abroad?
I think abroad. I think you need to get, as you were saying, Somenath, this thing that you were saying that you need to get exposed to different ecosystems.
Yeah.
So that's important.
That's important.
That's important to get a flavor.
One book which you can refer?
APJ Abdul Kalam, Wings of Fire.
Wonderful. That's your best one?
That's my best one.
Yeah. Okay, so out of all these conversations, what is the take-home message which my listeners can take?
I think be curious. Be curious. That will be.
Somehow it goes with my channel name as well. So I always say be curious and stay purposeful.
Yeah, that goes wonderful.
Because if you are curious, you will always have that intriguing mind running and asking questions.
Yeah.
And you will be purposeful.
Yeah.
You will be, because you'll find something out of that which can be deliberately or not deliberately also, but can be modified to some extent that way.
Being curious is, unless and until you have that, it's very difficult to step into academia, for example. So it just goes well, and that could be a starting point.
Yes. And even that reminds me of my somebody says a 4-year-old kid is much more curious than an adult.
Yeah.
And they are better researchers.
Yeah. They will ask you some questions which will like, okay, let me think about it, kind of like that.
Yeah.
But curiosity is something that if that stays throughout your life, well, I'll consider them as very blessed.
Very blessed. Yes. And what's the most obvious next move for someone who wants to do what you are doing?
Which phase of the career they will be, or
want to be a neuroscientist?
I think again, as I said before, got to be field awareness, like why you want to become a neuroscientist. That question is very important. So if sooner it gets deconvoluted in their head, the sooner they'll be able to select what path, because it comes very natural. It's one question linked to the other. So I think the first thing is awareness of your field, and that will tell you where your interests are, and then you can tailor your thing. And today is a world of internet, so you get all the information. But the main thing is the clarity in your head, what you want to do and why you want to do. It's a thing with why and what.
Yes.
So if you get that clarified in your head, I think it helps a lot.
True. That's, I think, a $1 million question. Why and what?
Why and what?
And in right time, if we can figure out this answer,
exactly,
we not only can save a lot of time, but we'll be always in the right spot.
Yeah, it's a game changer. Like anyone who is like in college or they simply don't take the pressure. Like, I think some of them could be a lot of pressure that this is what you would need to become. But instead of that, if they start thinking along these lines of why and what do I need to do, that will bring a lot of clarity in their mind. So that, I think that is very important, and as you said, the timing is very important.
Yeah.
So that will help people a lot, I think.
Absolutely. Can't agree more than this, right? Thank you, Dr. Poulomi.
Thank you so much.
I didn't feel like stopping. We could have gone, but yes, with the brevity of time, we
sure.
have to keep it short. And beautiful 2 lines, I'll be taking it. One, if you walk alone, you walk to a distance, but if you walk in a group, you go far away. Right? That's one thing I'm taking back today. Second is, yes, collaborations, reaching out to people, especially young students and all, they should figure out how and why, right? And outspoken. You have to be outspoken. You need to reach out to people. Be bold enough. Take the first move.
Absolutely.
What will happen at the max? They might say
no. Just that's a part of life,
Right.
So I think reach out, communicate better. That was one of your questions, I guess.
Yes,
I mean, communication is the key. So
communication is the key.
Yeah.
Yes.
Okay.
Thank you.
Cool. Thank you so much.
Thank you.